1 of the chapter 9, that is some applications of trigonometry. So looking at the very first question, the first question is, a circus artist is climbing a 20-meter long rope which is tightly stretched and tight from the top of vertical pole to the ground. Find the height of the pole if the angle made by the rope with the ground level is 30 degree. So just see in the figure, it is given that AB is the pole. So this AB is the pole here and AC is the rope here. AC is the rope here. So in triangle ABC, so we can see in triangle ABC, that is the right angle triangle ABC. So we need to find the, we have to find the height of the pole. So AB has to be, yes, we have to find the AB. So we know that AC is known and AB is unknown. So the relation between this known and unknown is sine 30. The theta is 30 degree. So right here sine 30 is equals to AB over AC. AB over AC. Now we know the value of sine 30 is 1 upon 2. Yes. And this AB over AC, the value of AC is 20 here. So on solving this, we'll get AB is equals to 10. So it means the height of the pole is 10 meter. Height of the pole is 10 meter. Now looking at the question number 2. In the question number 2, so what we can see here, we can easily see here that in the question number 2, yes, a tree breaks due to the storm and broken part bends so that the top of the tree touches the ground, make an angle of 30 degree with it. It means, now the meaning of this is that this AC is the height of the tree and it just broke from this point B. Now, so it means this AB comes towards the ground, right, and falls on the ground, and it means here that AB length is equals to BA dash now. BA dash now. So now we got a right angle triangle, that is BCA dash. So this angle is given 30 degree, means this is forming an angle of 30 degree when it touches the ground, the broken part of the tree, and the length of it from the foot of the tree is equals to 8 meter. It is also given. So what we have to find? We have to find the height of the tree. In order to find the height of the tree, that is AC, we need to find AB as well as BC. That is, we have to find BA dash, which is equals to AB and BC. So if you're looking here, so first thing, in triangle A dash BC, in triangle A dash BC, we can see here that BC over A dash C is equals to 1030. So value of 1030 is 1 over root 3. So A dash C is equals to 8. So we'll get here BC over 8 is equals to 1 over root 3. On solving this, we'll get BC is equals to 8 over root 3. BC is equals to 8 over root 3. Likewise, in the same way, we can say in the same triangle, we can also write that A dash C over A dash B is equals to cos 30. Cos 30. That is, yes, that means here base upon hypotenuse is equals to cos 30. So just putting the value, A dash C is equals to here 8 and A dash B we have to find, and root the value of cos 30 is root 3 upon 2. So on solving this, we'll get here A dash B is equals to 16 upon root 3. So height of the tree will be, that is AC, that is AC is equals to AB plus BC. So that means A dash B plus BC. So putting the value, that is 16 over root 3, 8 over root 3, that is 24 over root 3. Now we have to rationalize this because we can't put the root in the denominator. So multiplying both by root 3, so result will be 8 root 3. So 8 root 3 meter is the height of the tree. 8 root 3 meter is the height of the tree. Now looking at the question number 3. In the question number 3, it's a very simple question. It is written here or given here, a contractor plans to install 2 slides for the children in a park. For the children below the age of 5 years, she preferred to have a slide whose top is at the height of 1.5 meter and is inclined at an angle of 30 degree to the ground, whereas the elder children, she wants to have a steep slide of height 3 meter and inclination of 60 degree. So it means 2 things are given here. So first we have drawn the first figure for the first part, when the height is 1.5 meter, that is AB is 1.5 meter, and this angle of inclination is 30 degree. This is for the children's below 5 years. So we have to find the length of the slide. So again, in this right angle triangle, we can see that height is given to us and the angle is given to us. We have to find the hypotenuse. So using again, so writing of the language is very necessary, means writing at least 2 or sentences about the figure what you are drawing. So let AC be the slide. For the children below the age of 5 years, the height of the slide is 1.5 meter, inclined at 30 degree. Now in triangle ABC, we have AV over AC is equals to sine 30, because perpendicular upon hypotenuse is equals to sine 30. So putting the value 1.5 over AC is equals to 1 upon 2. So we'll get AC is equals to 3. So 3 meter is the answer of the first part. Now for the second part, we can see here in the second part what we have. In the second part we have the height is 3 meter. The height is 3 meter of the slide, and again we have to find the slide, and here this angle of elevation is 60 degree. This angle of elevation is 60 degree. So how to find this? So again using the same property, that is sine 60 is equals to perpendicular upon hypotenuse. So we have here AB over AC is equals to sine 60. The value of AB is 3. AB, that is 3 over AC is equals to root 3 upon 2. So it means we have AC is equals to 6 over root 3. Again rationalizing this, the result is 2 root 3. So height of the slides are 3 meter and 2 root 3 meter. So this is the answer of both the parts. Now looking at the next question, question number 4. So in the question number 4, it is given the angle of elevation of a top of a tower from a point on the ground which is 30 meter away from the foot of the tower is 30 degree. Find the height of the tower. So its distance of the from this point, the C is the point on the ground. From this, the angle of elevation to the top of the tower is 30 degree, and the distance of this point from the foot of the tower is 30 meter. So it means what we have to find here, we have to find the height. So it means height and base, that means perpendicular and base. So we'll take here sine 30 degree. So writing few one sentence about the figure, that is, let AB be the tower and C be the point 30 meter away from the foot of the tower. So in triangle ABC, we have AB over BC is equals to tan 30 degree. Putting the values, AB over 30 is equals to 1 over root 3. On solving this, we'll get AB is equals to 30 over root 3. Again rationalizing this, so result will be here tan root 3 meter. So height of the tower is tan root 3 meter. So simple thing we have to keep in mind is that we must be able to draw the figure. Once the figure is known and it is clear, then it's very easy for us to solve these questions. Okay, so again we can see in the question number 5, this is almost the same. Here we have to find the length. So the question is, a kite is flying at a height of 60 meter above the ground. So this is the position of the kite and it is 60 meter above the ground. The string attached to the kite is temporarily tied to the point on the ground. The inclination of the string will be at the ground is 60 degree. So this is the string of the kite. Find the length of the string, assuming that there is no slack in the string. Practically, when we see that string which we tied with the kite is not forming a straight line, it is practically curved. So but what we are writing here, or we are taking here no slack, means we are taking this as a straight string, not the curved one. So we have to find this length. So let K be the kite and P the point where the string is tied to the ground. So we have here, we can see here, so this is the point for the kite, this is the point on the ground. We have to find this length. So again we'll use here, now since the perpendicular is known to us, hypotenuse we have to find. So the relation will be sine. So we'll take here sine 60 is equals to KL upon KP, that is perpendicular upon hypotenuse. So that will be 60 upon KP is equals to root 3 upon 2. On solving this, we'll get here AB is equals to 120 over root 3. Again rationalizing both, so we'll get here 40 root 3 as the answer. So length of the string is 40 root 3 meter. 40 root 3 meter. Now moving towards the next question, question number 6. So we can see in the question number 6, a 1.5 meter tall boy is standing at some distance from a 30 meter tall building. The height of the elevation from his eyes to the top of the building increases from 30 degree to 60 degree as he walks towards the building. Find the distance he walked towards the building. So looking at the figure very carefully, So just looking at this figure, so this is the, we can see here, this is the height of the boy, which is 1.5 meter. So from this point the angle of elevation to the top of the building is 30 degree, and then he moves towards the point T. Now the angle of elevation becomes 60 degree, and the height of the building is 30 meter. Now what we have to find here, we have to find the distance he walked towards the building. It means this distance AB we have to find. So let PQ is the building, AS is the boy, 1.5 meter tall. He moves from S to T towards the building. So PQ is equals to 30 meter. This we know. Therefore now PR, the length of PR. So the length of PR means PQ minus QR. So PQ minus QR or RQ, we have 30 minus 1.5 meter, that is 28.5 meter, or we can also write 57 upon 2. It does not make any difference. Now moving towards the next step. So we have in the triangle PAR, so we can see in the triangle PAR, that is PR over AR is equals to tan 30 degrees. Okay, so keeping this, taking the triangle PAR, so this triangle PAR we can see here. So using the property, that is tan 30 is equals to PR over AR. Now putting the values, as we know the values, that is 57 upon 2 we have taken, over AR is equals to 1 over root 3. So AR is equals to 57 root 3 upon 2. In the same way we are taking the other triangle. So that is other triangle is means the triangle here, that is triangle PBR. So we are taking this triangle PBR. So in this triangle PBR what we have here PR over BR is equals to tan 60, putting the value of tan 60, that is root 3. Again remember that we are taking the known value and an unknown value. So that relation we are using here, that is trigonometric ratios we are using here. So just solving this, rationalizing this, the result is 19 root 3 over 2. So it means the distance walked towards the building will be ST. ST will be equals to AB, that is AR minus BR. So on just subtracting this, we'll get the result as 19 root 3 meter. So 19 root 3 meter is the distance he walked towards the building. Okay, he walks towards the building. Now moving towards the question number 7. From the point on the ground, the angle of elevation to the bottom and top of a transmission tower fixed at the top of a 20 meter high building. So this BC is a 20 meter high building, and this AB is a transmitter tower which is fitted or fixed at the top of this building. Now from the point D on the ground, the angle of elevation from to the top of the building and to the top of the that tower and the bottom of the tower is 45 degree and 60 degree. So now, so we have here, let BC is the building and AB is the transmission tower. So in triangle BCD we have, in triangle BCD, so first we are taking this triangle, we have two triangles here. So in this triangle we can see here that BC height upon perpendicular upon base is equals to tan 45 degree. So we have here 20 upon CD is equals to 1, or here CD is equals to 20. So this is CD is equals to here 20. Now in triangle ACD, now we are considering this one, the big triangle ACD. In this triangle ACD we have here AC upon CD. So in this triangle we have here AC upon CD, that is again tan 60. So AC can be written as AB plus BC. So AB plus BC over CD is equals to root 3. Putting the value of BC, it is given 20. So AB plus 20 over 20 is equals to root 3. On solving this, we'll get here AB plus 20 is equals to 20 root 3. That is AB is equals to 20. Root 3 minus 20. 20 as taken as common. So 20 within bracket root 3 minus 1. So this is the height of the transmission tower, that is AB. This is AB. Now then in the same way, in the question number 8, if you see in the question number 8 what they have given a statue 1.6 meter. The statue 1.6 meter is placed on top of a pedestal. So this BC is the pedestal. So from the point D on the ground, so the angle of elevation to the top and the bottom of the statue is 60 degree and 45 degree. So what we have to find here, the height of the pedestal, means we have to find here BC. So how to solve this? Looking here, so we have here that BC is the pedestal, AB is the height of the statue. So now in triangle BCD, so first we are taking this right angle triangle BCD. So in this triangle we have BC over CD. So we can see which is equals to tan 45 degree. So BC over CD is equals to 1, as the value of tan 45 degree is 1. So here BC is equals to CD. Now after this we consider the triangle ADC. In this right triangle ADC, we have AB plus BC over CD is equals to tan 60. Again we are taking perpendicular upon base. So we have here AB plus BC over BC is equals to root 3. Just putting the value of AB, which is equals to 1.6. So we have 1.6 plus BC whole over BC is equals to root 3. Now just on solving this, we'll get here BC is equals to 1.6 over root 3 minus 1. Now rationalize this by using the formula a plus b into a minus b is equals to a square minus b square. So we'll get here 1.6 within bracket root 3 plus 1 whole over root 2. So cancel this 1.6 by 2. So result will be the height of the pedestal is 0.8 multiplied by root 3 plus 1 meter. Okay, so if the value is given of root 2 in the question, or not given, if you are wish to write the value of root 3 like 1.732, so what you can do, then in that case you have to write your answer in approximation. If you are writing the answer in the root, then it is okay, it is accurate answer. But if you are converting the value of root in the decimal, then your answer should be approximately. Now so moving towards the next question, question number 9. In the question number 9, what we have, it is given that we have here the angle of elevation of the building from the foot of the tower is 30 degree. So we have one building and one tower, and the angle of elevation top of a tower, the foot of the building is 60 degree. If the height of the tower is 50 meters, so the height of the tower is 50 meter, and this building is AB, and the building is AB. So you can see in the building this AB. So angle of elevations are given here 30 degree and 60 degree, 30 degree and 60 degree. So we can easily see what we have to find here. We have to find the height of the building, that is we have to find AB here. We have to find AB here. So how to find this AB? So looking at carefully, in triangle CDB, in triangle CDB, we are taking this triangle. So first we'll find the base here. So we'll take perpendicular upon base is equals to tan 60. Just putting the values here, CD over BD is equals to tan 60, that is 50 over BD is equals to root 3, and that is BD over BD is equals to 50 over root 3. So then in the second part, now we'll take which triangle? Now we'll take this triangle, that is ABD. In this right angle triangle, again we'll take here AB we have to find. So we'll take perpendicular upon base is equals to tan 30. So this is AB over BD is equals to tan 30. So we have here AB over 50 upon root 3 is equals to 1 over root 3. On solving this, we'll get the result is equals to AB is equals to 16 whole 2 upon 3. So this is the height of the building, that is 16 whole 2 upon 3 meter, 16 whole 2 upon 3 meter. So moving towards the next question, the question number 10. So what is given here? It is given that two poles of equal heights are standing opposite each other on the either side of the road. So here this AB and CD are equal poles standing opposite on the opposite side of a road. So this BD is a road, so whose length is 80 meter, and there is a point between BD such that one angle of elevation 60 degree, other angle of elevation is 30 degree. So we have to find this OB, we have to find this distance OB and OD, and we have to find the height of the pillars also, or the poles also. So let BD is equals to 80 meter wide road, and AB and CD are the two equal poles. So let AB equals to CD is equals to X. So we have taken here this as X, and this is also as X. Now so in triangle ABO, so looking at in triangle ABO, we have here AB, that is perpendicular upon base is equals to tan 60. So AB over B is equals to tan 60. So X over BO is equals to root 3. So BO is equals to X over root 3. Now after this, we'll consider the triangle that is CDO. Now in this right angle triangle CDO, again perpendicular upon base is equals to tan 60 degree. Now here OD will be taken as 80 minus OB, 80 minus OB. So now we can see here that CD over OD or DO is equals to tan 30. Just putting the value, X over 80 minus BO is equals to 1 over root 3. So here we are getting X root 3 is equals to 80 minus BO, and we know the value of BO is X over root 3. So just putting the value here and solving this, equation, we'll get the result as x is equals to 20 root 3. So therefore BO is equals to x over root 3, that is 20 root 3 over 3, which is equals to 20. Likewise, so DO will be BD minus BO, that is 80 minus 20 is equals to 60 meter. So here we are getting all the three values. The height of the poles, both the poles is 20 root 3 meter, and the distance between these are 20 meter and 60 meter respectively. Okay, so moving towards the question number 11, right? So in this question number 11, what is given? A TV tower stands vertically on a bank of a canal. From the point on the other bank, on the other bank directly opposite to the tower, the angle of elevation to the top of the tower is 60 degree. So the angle is 60 degree from this point. Now when from the another point which is 20 meter away from this C, that is this distance is CD is equals to 20 meter. Now the angle of elevation will become 30 degree. So what we have to find here, we have to find the height of the tower and the width of the canal. So we have to find AB, as well as we have to find the length. Which length? We have to find this length, BD. Okay, how to find? So just looking here. So let AB is a TV tower, BC is the width of the canal. Okay, so width of the canal we have to find. The width of the canal is here BC. So we'll take here AB over BC is equals to 1060, that is, so in triangle ABC we'll consider the triangle ABC. So in this triangle ABC we have perpendicular upon base, which is equals to 1060. So AB over BC is equals to 1060. So AB over BC is equals to root 3, and BC is equals to, we have AB over root 3. Now just remember this figure. Now then we'll consider which the other triangle, that is triangle ABD. Now in this triangle ABD we'll take here, we have now AB over BD is equals to 1030. So just putting the value AB whole over BC plus CD is equals to 1 over root 3. Now just putting the values from the first equation and solving here, we are getting the result as AB is equals to 10 root 3. So AB is equals to 10 root 3. Okay, calculations you can easily solve by yourself. Now therefore BC is equals to AB over root 3. So we have 10 root 3 over root 3. Root 3 cancel. So we have 10. So it means the height of the tower is 10 root 3 meter, and the width of the canal, that is 10 meter. Okay, clear? Next question. So now in the question number 12, what we have in the question number 12, it is given that we have a building with a height 7 meter, and there is a cable tower, that is CD is given to us, and from this top of the building, that is from point A, the angle of elevation to the top of the tower is 60 degree, and the angle of depression to the foot of the tower is 45 degree. Now what we have to find? We have to find the height of the tower, that is we have to find the height of the tower. It means we have to find this length CD. How to find this? Look here. So we have here triangle ABD. So in triangle ABD we can see here, now we have here perpendicular over base, so that will be AB over BD is equals to 1045. On solving this, 7 over BD, that is BD is equals to 7 meter. So well, length of BD is known now. BD is equals to AE. As you can see clearly that it is a square, so this length is also 7. Now after this we'll consider triangle ACE. Now in triangle ACE, this is known to us. Now this we have to find again using the perpendicular upon base, that is 1060. So using this, CE over A is equals to 1060, putting the value CE over 7 is equals to root 3, and C is equals to 7 root 3. So now therefore value of CD, since we have to find the value of CD, so CD is CE plus ED. So right here CE is equals to CE plus ED, CD is equals to CE plus ED, 7 root 3 plus 7, that is 7 bracket root 3 plus 1. So this meter is the height of the cable tower, is the height of the cable tower. Now looking at the question number 13, so in the question number 13, an observer at a top of 75 meter high lighthouse. So observer standing at this point A, and what he's observing that two ships are moving towards the lighthouse, and the angle of depressions are 30 degree and 45 degree. So one ship is at position C, one is at position D, and they are in the same direction. We have to find the distance between the two ships, that is CD is we have to find. Okay, so what is given here? AB is given here, and the angles are given here. So this angle is also taken as 45 and 30. Reason is because we are taking here alternate interior angles. Now So first we consider triangle ABC. In triangle ABC we have AB over BC is equals to 1045, that is 75. BC is equals to 1 or BC is equals to 75 meter. Now in triangle ABD we have perpendicular, that is AB over BD is equals to 1030. So putting the value AB 75, BD can be written as BC plus CD. So we have here 75 or BC plus CD is equals to 1 over root 3. Just on solving this equation we'll get here CD is equals to 75 within bracket root 3 minus 1 meter. So this is the distance between these two ships. This is the distance between these two ships, and here this is distance is given in, okay, the height is given in meters, so distance will be also in meter. Now moving towards the next question, question number 14. So in the question number 14, as we can see that a 1.2 meter tall girl, so girl is here, spots a balloon moving with the wind in the horizontal line. So spots a balloon, so this is the initial position of the balloon and this is the final position, is moving towards in this direction, in the direction of the wind, and the height is 88.2 meters. So the height of the balloon from the ground is 88.2 meter. The angle of elevation of the balloon from the eyes of the girls at any instant is 60 degree after some time. So at the first instant is 60 degree, so this angle is 60 degree here, and after some time this angle converted to 30 degree. So what do we have to find? We have to find the distance traveled by the balloon. So distance traveled by the balloon is this much. This is the distance traveled by the balloon. Okay, so looking at this now, so what we have to find here, we have to find this distance, that is we have to find here EG we have to find. So for that first we'll consider this triangle, that is triangle ACE. We'll take a triangle ACE. So looking here carefully, so in triangle ACE we consider this AE and EC. Now the length of AE, the length of AE is not 88.2 meter, it is 88.2 minus 1.2, that is 87 meter. So now solving this triangle, we have in triangle ACE AE over CE. AE over CE is equal to 1060. So putting the values here, now AE can be written as AF minus EF. So that is 88.2 minus 1.2, which is equal to 87. So 87 upon C is equal to root 3. Root 3 is the value of 1060. On solving this, we'll get here C is equal to 29 root 3. Now in triangle BCG, now in triangle BCG, now in this triangle, so we'll have here again the perpendicular and the base. So perpendicular is known to us, so we have here BG over CG. So what is BG? BG is this much and CG is this much. Okay, so putting the values again, 88.2 minus 1.2 over CG is equal to 1 over root 3. 1 over root 3 is the value of 1030. So we have here CG is equal to 87 root 3. Now since we have to find the distance traveled by the balloon, so that is equals to EG we have to find. So EG can be written as CG minus CE, which we have already found here. So putting the values, 87 root 3 minus 27 root 3, that is 58 root 3 meter is the required answer. This is the distance traveled by the balloon. Okay, next is question number 15. Okay, so again a very good question. Looking here carefully, in this question it is given a straight highway leads to the foot of the tower. So AB is the tower, an observer is standing here, and what he found that once the car is at the point C, and within the 6 seconds the car reaches at point D. Now the angle of depression changes from 30 to 60 degree. We have to find how much time will be taken by this car to reach the point B from D. So this time we have to find. So look at the question carefully. A straight highway leads to the foot of the tower. A man is standing at the top of the tower, that is at point A. Observe the car at an angle of depression of 30 degrees. So this angle is 30 degree, which is approaching the foot of the tower with a uniform speed, and 6 seconds later the angle of depression of the car is found to be 60 degree. Is found to be 60. From 30 it becomes 60 degree after 6 seconds. So find the time taken by the car to reach the foot of the tower. So we have to find the time taken by the car to reach the point B here from D. Okay, so look here. So now let CD is the highway and AB is the tower. C is the initial position of the car and D is the position after 6 seconds in triangle ADB. So in triangle ADB, what we can take here, we write here perpendicular upon base. So that is AB over AD is equal to 1060. That is AB over DB is equals to root 3 and DB is equals to AB over root 3. So in triangle ABC, so here we are getting the value of DB is equals to AB over root 3, that is DB. Now in triangle ABC, now we'll take this triangle ABC, this bigger triangle, and here we have AB over BC is equals to 1030. So from here we'll get here that AB, now BC can be written as BD plus CD is equals to 1 over root 3. So here we are getting AB root 3 is equals to BD plus CD. AB root 3 is equals to BD plus CD. So after this, we can see here, now this can be written as AB is equals to AB over 3. Just put in the value of BD here. So we'll get this equation. Now then putting the values, what we are doing here, we are just taking this to the right side. Okay, just on solving this we'll get here DC is equals to 2AB over root 3. Now since we have to find the time, so time means what we have to do, we'll take here the time taken to travel CD is equals to 2AB over root 3 is equals to 6 seconds. So time is here 6 seconds, and therefore the speed of the car. So what we'll do here, we just put the values here, distance upon time. So distance is 2AB root 3, time is 6. On just solving this here, it is given here 2AB. So write here 2AB over, now this root 3 into 6 will be multiplied. So this is 2 into 1 and this is 2 into 3. So what we are getting here, we are getting here AB over 3 root 3 meter. So time taken to travel BD will be AB over root 3. So that is distance upon speed, so which is equals to 3 seconds. So here we are getting here AB over root 3 over AB over root 3 is equals to 3 seconds. Means what we are doing here, we are just solving this, we are just putting the values from these equations. So the result will be 3 seconds is the answer. Now okay, now moving towards the last question. The last question, again a very good question. In this question they are saying the angle of elevation of top of a tower from 2 points at a distance of 4 meter 9 meter. So this is the height of the tower. So A Q is the tower and the distance is 4 meter and the 9 meter from the foot of the tower. So this is the two distances are given here, and the angles are given, the relation between the angles is given, the angles are complementary. So if this angle is theta, this is 90 minus theta. What we have to prove, we have to prove that the height of the tower is 6 meter. So looking here, we have here, let AQ be the tower, C and D are the 2 points 4 meter and 9 meter away from the foot of the tower. The angle of elevation are complementary. So one angle is theta, other angle is 90 minus theta. Now in triangle AQR, so in triangle AQR, what we have, AQ over QR is equals to tan theta. So that is AQ over 4 is equals to tan theta. Likewise in triangle AQS, if we consider the triangle AQS, this whole triangle, then we have perpendicular upon base is equals to tan 90 minus theta. So tan 90 minus theta, that is AQ upon QS is equals to tan 90 minus theta, that is AQ upon 9 is AQ upon 9 is equals to cot theta, because tan 90 minus theta is cot theta. Now multiplying both the equations, what we are getting here, we are getting AQ over 4 into AQ over 9 is equals to tan theta into cot theta. On solving this, we'll get here AQ is equals to plus minus 6. So plus minus 6. Now this is clear that height cannot be negative, so the height of the tower is 6 meter. So hence we have proved this. So in this way you can solve the questions. Okay.